All right, Pythagorean Theorem. So you've probably seen the Pythagorean Theorem before. What's new now is it's a theorem, so we're going to think about a proof. We're not really going to go into detail with the proof today, but I'm just going to show you an illustration of the Pythagorean Theorem instead. So the Pythagorean Theorem says A, B, and C. This is a 90-degree triangle. If, and I'm going to use the if and only if here. If and only if triangle ABC is a right triangle, then A squared plus B squared equals C squared. And so there are two main uses for this. One is we can find the length of one of the sides. Right? So if I gave you A and C, you could use this formula to find B. Does that make sense?
Yep.
The second one is if I gave you three sides, you could tell me whether or not the triangle was a right triangle. Okay. So let's do an example of those. So is this a right triangle? 3, 4, and 5. How will we know if that's a right triangle or not?
If they tell us. If
It's not.
if A squared plus
Yeah, if A squared plus B squared equals C squared.
Oh,
C is always the hypotenuse.
Yeah, no, wait.
So what do? We take 3 and we square it, that's 9. We take 4 and we square it, that's 16. Does that equal 5 squared, which is 25?
Yeah.
Yes. So 3, 4, 5 is a right triangle. Oh. Maybe all sets of 3 sequential numbers are right triangles. Is this a right triangle? 4, 5, 6?
probably
16, 25 equals
No.
35.
So yeah, we square 4, that's 16. Plus we square 5, that's 25.
plus 36.
Does that equal 36?
No.
No. No. That is not a right triangle.
It would be kind of cool if like 3 sequential numbers did
Always made a right triangle.
Yeah.
Yeah, I think 3, 4, 5 is one of the only ones. There might be another one, like, I can't remember. I don't think there is actually. So when you study geometry more in depth, you will actually study the right triangles. And you'll learn, okay, these are the right triangles. And there's certain ones that are kind of known, like 3, 4, 5.
Why would you study right triangles?
There's one that's an isosceles. Right? Is that the right term? Isosceles where two sides are equal. That's a right triangle. And that's 1, 1, and what would the third side be? Well, let's use the Pythagorean Theorem.
2.
1 squared plus 1 squared equals, we'll call this C squared. So what is 1 squared plus 1 squared?
2.
2 equals C squared. So what is C?
2.
Take the square root of both sides. C equals the square root of 2.
Oh god.
So this is another commonly known right triangle, 1, 1, square root of 2. The cool thing about this is you'll start to recognize patterns because you guys have learned about similar triangles, right? So I know that a triangle that's similar to this will also be a right triangle. So for example, if I saw triangle, what's up with my markers today? Yeah, exactly. If I saw the triangle 6, 6, yay! 8, well, this one sort of works. And 10, I know that that's similar to 3, 4, 5, so it's going to be a right triangle too. Okay. So I just want to show you an illustration of the Pythagorean theorem. We're not going to try to prove it.
Got it.
But I do want you to think, and this is actually related to one of the proofs for the Pythagorean. So if we have a right triangle, what does the Pythagorean theorem actually say? Well, what it says is that the area of this square plus the area of this square is equal to the area of this square. That word. And this is, I think, one of the coolest examples of a connection between geometry and algebra. You've seen like a squared before, but a squared is actually literally a square. What it means is a square where both sides have a length of a. Because then the area of that is a times a. B squared means a square where both sides have a length of b. So the area is b times b, which is b squared. And c squared is a square with, I'm saying both sides, all four sides are equal to c. And the area is c times c, or c squared. So this is really the Pythagorean theorem. And if you want to look on YouTube, there's a cool video of this guy who built a contraption of this. Like he actually built this out of wood or something like that, and then plastic. And he fills up these two squares with blue water or something. And then he flips it, he made it so he can rotate this thing, and the water drains out of these two and exactly fills up this square. Right? Which is what the Pythagorean theorem says, but it's just cool to actually see the physical representation of that. And that's another sort of proof. I mean, it's not exactly a proof, but it's another way of thinking about a proof. And the proof for the Pythagorean theorem is fairly complicated. It's not very intuitive. It involves a lot of constructions, at least the proof that I know. But we're not going to look in depth at it today. I just think it's cool to visualize what it means too. All right. And so another way of saying the Pythagorean theorem is the square of one leg plus the square of the second leg equals the square of the hypotenuse. That's another way of saying this. And with this diagram, I think that makes a lot of sense. The square of this leg is this square right here. Right? And the square of the other leg is this square here. And the square of the hypotenuse is this whole thing.
It's like a baby square that's wearing a diaper.
Mm-hmm.
Oh, I see.
Any questions about that?
Mm.